Hello everyone. So we're going to talk today about breaking digital assets custody solution. So, Okay, so yeah, more intro about me. I'm senior security architect at Halborn. My background is vulnerability research and offensive security operation over like 7 years. Mostly like iOS and Windows in terms of vulnerability research and red team in terms of offensive security. Right now doing R&D at Halborn and yeah, bounding around and stuff. You can follow me on Twitter. Yeah, so more about us, Halborn. We are like specifically as R&D, we have found like some 0 days, a lot of them, a lot of vulnerabilities. This is one of the most two famous vulnerabilities we have disclosed recently, the minimalist wallet, and the one I personally found is the Dogecoin vulnerability, which is affect also 280 network. Yeah, this is what the brands we are working with. Yep, so today's agenda, we're going to talk about what's the digital asset security custody solutions. We got to talk about MPCs, some cryptographic stuff, and we got to talk about real vulnerabilities. And this original presentation has been like for 1 hour long presentation, but it has been like squeezed to just fit the timeline we have today. So like what's DAX or digital asset custody solutions? Like banks or centralized exchange, they're not holding their assets differently like in MetaMask wallets or their own self-custodial wallets. They have like a more complicated procedure to execute large transaction, let's say, to move like from treasury to another one. And they are using technically something called like custody solutions. This is just a market overview. I believe that this slide is really out of date because right now the market value is really different than the one we are seeing here. Yeah, so what's the difference between your MetaMask wallet or your self-custodial wallet versus like a really enterprise-grade kind of digital asset custody? So your wallet's like small amount. When we talk a small amount, it could be like some few millions of dollars. That's considered small amount for the amounts operated through custody solution, enterprise-grade custody solutions for big financial institutions. Simple cryptography, digital signatures, it could involve like some multi-sig, some simple multi-sig wallets. You're using it like normal users are using it, like not financial institutions, not crypto exchanges and stuff like that. But for digital custody solutions, banks are using it. Like this is where banks are storing their digital assets like Bitcoins or ETH or any kind of cryptocurrencies. And also like centralized exchange, so like when they're holding their liquidities and stuff like that. The transactions is like more frequent, large amounts. It could be like billions of dollars in some cases. In terms of the cryptography behind that custody solutions, it's mostly like MPC protocols, shareholder signatures, keys, and other complex cryptographic protocols. We got to talk about each one of them. So yeah, it's simple as that. Like when you are initiating a transaction from your self-custody wallet, it's just like a few buttons. Maybe you're entering a password. But for a custody solution, like I have seen something close to that one, like kind of custody solutions where you have some people like required to enter a specific room, use like specific laptop or an iPad to sign a specific transaction and stuff like that. There's a lot of procedures like for that, mostly for financial institutions. So yeah, there's stuff like that for digital custody. So why we should care about digital custody securities? Actually, like the digital custody solutions, they are designed for security, like to provide security for the digital assets. So that like I would call them like a security product or a product have been built with a lot of security consideration would make it like really hard to break. But let's assume like two following scenarios, like in Web 2 space and Web 3 space. In Web 2 space, we are breaking into a financial institution, we are gaining access, we are becoming like domain admin, stuff like that. We are compromising like the SunGuard or the SAP start to craft like some Swift messages. Yeah, that would work like 10 years ago, but right now it's like more complicated stuff. Like, yeah, when attackers like gain that much access and they start to actually craft this kind of messages, yeah, there's a lot of procedures, action response. So, like, it will not work that much easy. But in Web3, like, you can just like gain control over the infrastructure, and this is definitely optional because you can do like some cryptographic attacks, some smart contract attacks if smart contracts are part of the system. You can compromise like the key materials or the private keys, and like just sign your transaction, send your transaction, and all of your funds gone. It's that much easier in Web3. That's why like threat actors nowadays are focusing on more attacking like kind of Web3 institutions and Web3 related stuff other than regular financial institutions because it's really easy to make profit over them. So yeah, that's like a kind of compromise scenario of a normal, let's say, a centralized exchange. They're not using any kind of custody solutions. So the attacker is just compromising the operation machines, and the operation machines interacting with the backends to handling the private key, let's say, and sign kind of some kind of transactions, and they just send this transaction, broadcasting it to Bitcoin node. But in a secure scenario, or like where is that exchange using kind of custody solutions? So we will have something like this one's a function inside, it's like the custody solution, let's say, or like the multi-secure competition or whatever. So when the attacker is trying, oh, okay, I want to initiate a request for transferring $1 million, there's like kind of a part of the custody solution, it's like kind of a policy manager. We'll talk about this. A regular policy manager will like give some alerts, initiate some MPC and start to like ping people. They have been transaction. People will just like kind of, okay, reject the transaction. It's not us. And yeah, the attack will fail, or the attacker will be like, not really able to take the money out. So yeah, the core functionality of a custody solution is like MPC or TSS or multi-signatures. They are not all the same, definitely. So like the MPCs use like multiple parties coming together to compute a value based on like private inputs. TSS is like distributed key generation, and the multi-signature wallet is like just like multi-signatures we are using almost like every day in our crypto life, where we like have a group of people trying to authorize a specific transaction. So we'll talk more about MPC because MPC is like the core part of a custody solution, but definitely there's a lot of other things related to custody solutions like communication channels, but the core thing is happening inside the cryptographic primitives of the custody solution, which is mostly based on MPC. So MPC is not like an actual cryptographic protocol, but it's more like hashing. Like when I say hashing, like there's a lot of functions can come to your mind to make the actual hashing. It's the same for MPC. You can employ like multiple cryptographic primitives to build like an MPC or multi-secure competition. So it's early in 82, like some historical stuff, and the MPCs that when cryptographer actually started to talk about MPC, it wasn't really about cryptocurrencies and digital asset security or digital transactions, because that time they didn't have kind of this stuff. So some research, yeah, definitely they are not like publicly classified informations, but most of like the MPC research paper was related to some military activities that time, when they are like launching missiles and stuff like that. So nowadays, we have like really common papers for the digital asset security, like people who's building like custody solutions. This is the most top protocol I have seen when people are implementing their own custodies or the custodies that have been auditing. So like GG, good game. But generic Goldfeather, that's the most common one I have seen. And DMZ, I don't know what DMZ is standing for, but there's a lot of open source libraries using DMZ paper implementation. So not about like when you start to the end like the GG protocol or the G implementation, you will see like there's a lot of research have done like attacking these protocols actually, and there is no one attacks. But people like, for example, when you just like grab this repo or you're trying to implement your own protocol, you're not gonna really like scroll down to all the references. I know. Okay, yeah, definitely you will check the security because there's something security, but you will not read each like kind of research paper. That's really time consuming. But there is a lot of learning attacks on the GG protocol, but it's still commonly used. Easy to find bugs, let's say, because for example, when I'm getting an audit, they're using like GG protocol. I'm not saying GG protocol is not secure, but yeah, it's more common to find implementation errors within the protocol. So ways like to do like the MPCs, it can be done like through secret sharing schemes like streamer secret sharing or shell secret sharing and other cryptographic primitives. You can just put all together and create your own MPC. Like if you're a cryptographer, I don't recommend you to do that definitely. So what do you need to break a digital asset security custody solution? So you need to like have a breaker mindset, read some codes, some masses required, I do believe. Understanding like digital signatures definitely, but yeah, I mean the actual core of custody solution is more in terms of cryptography stuff, but you can still break a custody solution like attacking their like web interface or the API interface or other stuff. Yeah, this can work, but you can also attack the cryptographic bar stuff. Trust no one. Every component inside the actual custody solution is, let's say, is a vulnerable because like this threat modeling of a custody solution is like should be kind of rated completely different other than a normal software because, for example, you don't even trust your CPU or operating system, and we're gonna talk about that in a moment. Yeah, work at Hossam if you want. We are hiring. If you're interested in this stuff, you can ping me after the talk. So yeah, we're gonna talk about red flags when we are starting like kind of engagement with auditing digital asset custodies. So the most common red flags is, and by the way, this flag has like some real scenarios, but I have just squeezed it because of the time. So yeah, we are running our own implementation of the cryptographic protocol, or we are started our own MC implementation or CSS implementation. That's a red flag, and we're going to talk about this in details. We don't have secure enclave or trusted execution environment. Or, okay, we have secure enclaves, we have HSMs, but we don't know like the context management and domain management, C and C++, and or unsafe memory languages. So we have like first scenario, we are running on our implementation. We are running our implementation could be like closed source implementation or it could be an open source. The actual argue is not related to whatever it's open source or closed source implementation. It's just like their own implementation because most of the people, they don't have access to like rockstar cryptographers where they will be able to implement a protocol like error-free or bugs-free. So that's definitely kind of a red flag and requires definitely more work from you in terms of audit, in terms of securing this product because it's me. You're gonna read and inspect a lot of code. So how you break that or how you solve that. So you need to understand the actual protocol. Like you just drop the client code and go understand the actual protocols they are trying to implement or the actual paper. Yeah, definitely reading research papers is not that much easy. Like definitely if you're not like a cryptographer, but I do believe like having the basics math of computer science level math, you will be able to understand the paper. But yeah, if there's some parts of like linear mapping, for example, like you don't understand that, you just go ahead and Google it. Like we are internet age, you don't need to go to the library and look at Fatbox. Yeah, so. Review the implementation. Try to identify like the core points of the implementation, like for example the key generation flows, the actual protocol steps, verification and signing. And once you spot this few entry points, you will go and identify the same entry points in another implementation of this protocol or open source implementation of this protocol. You might not find them, but try to, for example, if they're using, for example, the other implementation of protocol, for example, they are using like a entire different curve. So you will start questioning why is these people in their implementation using this specific curve, and you might start the client asking the client some questions, and you might come up with a finding. So the other one is like we don't have secure enclave or trusted execution environment, and this is like breaks the actual idea of custody solution, because it's mean you're running you're processing your key materials or your private keys or your cryptographic operations on pair machines, I will say, or for example, if someone compromises your machines, they can just dump your private key. So like there's kind of no security. So you don't need to break it because it's already broken. So there's no custody solution or kind of MPC running outside of trusted execution environment that's completely broken thing. Okay, but we have like trusted execution environment. We have like secure enclaves, but we don't know how to manage the context, or we fail to manage the context management between both of them. For example, we are doing like kind of we are extracting the key materials from the secure enclave, and we are processing them into like as a web app or the API. And we keep them like we are not zeroing the values or whatever, so the key can be extracted around time in case of the compromise of the untrusted domain. And the untrusted domain is, let's say like, okay, all of your cryptographic stuff are running inside the trusted execution environment or secure enclave, but the attacker gain access to your like web interface or the web app container, or they start like you are already dealing or you're executing some calls to your secure enclaves, and you are keeping your private key stored in like in a variable or whatever. So that's where you are failing to manage the context between the secure enclave or trusted execution environment and your untrusted domain, which is like the interfaces or your APIs. So you're like C and C++, like that's it, like C and C++ using memory safety issues is really common, for example, at the communication level, because it will help you exploit the untrusted context, let's say. Maybe that will lead to further attacks, but definitely like most of the cryptographic protocols are user implemented in two languages that have parity. It's like C and C++ or Rust. There's like some TypeScripts, but it's not really common. But most of them like are in C and C++ because people are just getting on-shell cryptographic primitives from other libraries, and they start to use it in their own implementation. So also like academic people are more comfortable writing in C and C++ code. So it's more like you're starting to write kind of the message processor or the message parser or the communication parser in C and C++ as well. So I have seen like some issues related to that one, where you don't need to attack the actual cryptographic protocol, but you're just attacking the memory safety of C and C++, like, or the communication protocol, causing like some heap overflows in the case I had. So like how to break it is exploit some memory corruptions, because I don't think there is any advantage for the attackers to see inside C, C++, inside the custody solution other than memory corruption vulnerabilities, because yeah, it's definitely they saw like some cryptographic flaws. That's an entire different thing. Yep, so that's all for today. Any questions so far? Complicated topic, right?
Questions? Give it up to Hossam.
Okay, thank you.